So in this video, we're going to be looking at how to subtract whole numbers. This is a follow-on from our last video on adding whole numbers and using addition. And so that's kind of a prerequisite. So at least having a good understanding of how to add numbers, how to line them up so the place values align when you're adding them manually, and having those kind of fundamental skills will really help you progress into this video here. So, what is subtraction? Well, subtraction is the operation just like addition was the operation, and we use the operator which looks like a dash, and so this means subtract. You put that in between your two numbers and essentially you'll end up with an expression. So an expression as an example might be 7 minus 3. So that's how you read it, and the result of that expression on the other side of the equal sign would be the difference of 7 and 3. And so very importantly, in addition, there was a commutative property that said a plus b equals b plus a. In other words, any number added to another number, you can swap the order of those numbers around and you'll still get the same answer. That isn't true with subtraction. And so if you could imagine 7 minus 3 actually equals 4. However, if I swap those numbers and I put 3 minus 7, I would actually end up with negative 4. And so there is a difference there. So let's have a little bit of practice translating from math notation to words. So we have a, which is the number 8, and then the subtraction operator, which looks like a dash, followed by 1. And so the way that we would phrase this would be 8 minus 1. And then for b, very similar, we'd end up with 26 minus 14. And so to extend upon that, we would then for a say that the result of subtracting 8 minus 1 would be the difference between 8 and 1. And so similarly for b, the result would be the difference between 26 and 14. So subtracting whole numbers. Really important to understand this concept. So just like addition, subtraction is actually an inverse operation of addition. Effectively, what this means is that if you want to subtract something and then you find the difference, you can then recreate that initial value based on using addition. And so addition undoes subtraction and subtraction undoes addition. In the examples here, you can see that 7 minus 3 equals 4, and therefore I can say that 4 plus 3 equals 7. So you can see how that undoes it. So we add the 3 back, which we subtracted initially, and we end up with the initial number that we started at. So in this second case, if we start at 13, we subtract 8, we get 5. If we add 8 back to the 5, then we'll get back to 13. And similarly, for 43 and 26, when we find the difference between 43 and 26, we find out there is a 17 unit difference. And so if we add 26 back to 17, we would then get back 43. So just to recap, because it's very, very important as we move into algebra, addition undoes subtraction and subtraction undoes addition. All right, so a couple of examples. So we're going to subtract and then check by adding. So for A, we're trying to find the difference between 9 and 7. So we would rewrite the expression 9 minus 7. Now the result would be 2. So 7 less than 9 would be 2. Now, if I want to make sure that I'm right, I would then re-add this 7 here. So we would end up with 2 plus 7 is equal to 9. So just so that we understand here, this 2 is this 2. This 7 is this 7, and this 9 is this 9. And so we can check, make sure we've got all the same numbers, and we're correct. So for B, we're trying to find the difference between 8 and 3. So we can say 8 minus 3, which equals 5. Therefore, if I add back that 3 to 5, I would then end up with 8. So subtracting numbers with more than one digit can be quite tricky. We have to think back to our addition video where we lined everything up in columns and worked with individual place values. So we make sure those places are aligned. And that's the number one step to being successful with both addition and subtraction. So the steps here that I would suggest to write down as we start to approach some practice problems would be, 1, we need to write the numbers vertically in columns so each place lines up. Then 2, we subtract the digits in each place value. So we work from right to left, starting with the ones place. If the digit on top is less than the digit below, we would then need to borrow. So instead of carrying, as we did in addition, we end up borrowing. And so this might be quite intuitive for some, but for others, we need to think about the fact that they're inverse operations. So if addition undoes subtraction and vice versa, we can think if we're carrying one way, then we're going to be borrowing the other to get that value back that we would have added on, if that kind of makes sense. And so next we want to continue subtracting each place value from right to left and borrowing if needed. And then finally check by adding. For now, I would suggest to check by adding. However, as we continue to move forward, you can kind of neglect to do that as you become more and more confident with using subtraction. So let's start with subtract, then check by adding 89 minus 61. So I want you to think for a second. Just like we had that commutative property of addition, can I just say 61 minus 89? Will that be the same thing? Nope, it won't. You'll actually get back the wrong number. And so it's really important that we think about the numbering in this one. So when we're lining up our columns, we have to have 89 at top and 61 below. So we'll do that first. So 89, 61, and then a negative sign. Then we put our underline and we work down from the right-hand side. So 9 minus 1 is 8, and 8 minus 6 is 2. And so we should then think, okay, I've got 28 out of that. What would I have to do to get back to that 89? Well, then I would have 28. So let's put that there. So 28, and then we'd have to add the thing we subtracted. So we'd add 61. So now 8 plus 1 is 9, and 2 plus 6 is 8. So this 89 is equivalent to the 89 that we started with. So we are correct. All right, second example, we want to subtract 26 from 43, or find the difference between 43 and 26. So we write 43 on top, then minus 26, then we underline. Now this is an example where we'll use borrowing. So because we can't say 3 minus 6, what we need to do is we need to take 1 from the tens place. Now it's really important that you understand what's really happening here. So when we're borrowing, if we take 1 from the tens place, we're not taking a 1, we're taking a 10. So really, if we borrow and this becomes 3, then that becomes 10 plus 3, or 13. So because we're taking from the tens place, that's how that works. And so we would say 13 take 6. And so that would be 7. Then we'd have 3 take 2, which is 1. So students can get quite tricked up there, but you need to remember which place you're taking from. Finally, we need to check by adding. And so we would need to add 26 that we subtracted initially to 17, and hopefully we find 43. And so one way you could think about this is if I move this underline here and pretend that one's not there and then change this to a plus, then we have 26 plus 17, we should get 43. And so we'll check that now. So 26 and 17 added together. So 6 plus 7 is 3, or 13, and then we want to carry the 1. So 1 plus 2 is 3, plus 1 is 4. And we end up with 43, which is the correct number that we wanted to get. Okay, another example, subtracting and then checking by adding 207 minus 64. So this is an important example for understanding how to line up the columns appropriately. So I'd write the 200 and then I would remember that I don't have a hundreds place in the second number. So I would just write 64. So then you do the underline and you do the exact same process. So 7 minus 4 is 3. 0 minus 6. How do I do that? Well, then I have to borrow from the hundreds place. And so what I really do is I just kind of think to myself, okay, this will become 1 and this will become 10. Then we would end up 10 minus 6, which is 4. Now we still have a 1 in the hundreds place, so we have to remember just to carry that down because there's nothing we're subtracting from. So 1 minus 0 effectively would still be 1. And so we get 143. Now to add back, I would say 143 plus 64, and we should get 207. So 3 plus 4 is 7, 4 plus 6 is 10, so we put the 0 there, carry the 1, 1 plus 1 is 2, and so we get 207, so we know we're correct. So another example, now we've got two hundreds place values, so we've got 910 minus 586, so we want to put the 910 on top, 910 I should say, subtract 586, and so 0 minus 6, well we can't do that, we have to borrow from the tens place, so we cancel that, that becomes a 0, and this becomes a 1, so we've got 10 minus 6, which is 4, then we have 0 minus 8, well again we can't do that, so we borrow from the next one to the left, and so we end up with 8 here, and then we carry 1 over to the, or borrow 1 to the next place, so we get 10, so 1 and the 0, minus 8 is 2, then we get 8 minus 5 is 3. And so we should be able to add 324 and 586 together to get back 910. So that's right, 324 plus 586. And now we've got 4 plus 6, which is 10. So we carry the 1 over. Now we go 1 plus 2 is 3, plus 8 is 11. So we've got the 1 there from the ones place, carry the next one over. So then we get 1 plus 3 plus 5. So we get 9, which is 910. All right, now we need to subtract and check by adding again. This time we've got a thousands digit. So we've got 2,162 minus 479. Key thing here is to make sure our places are lined up, and they are in this example. Now we've got 2 minus 9. Well, we can't do that, so we have to borrow. So this 6 becomes a 5. This becomes a 12. And then we go 12 minus 9, which is 3. Now we go 5 minus 7. We can't do that, so we have to borrow from the next place over. So that becomes a 0. This becomes 15. And we get 15 minus 7, which is 8. Then we go 0 minus 4. Well, we can't do that, so we borrow from the next place over. We get a 1 there, and this becomes a 10. 10 minus 4 is 6. Now we've got to make sure we put our comma, and then we just carry that 1 down. So we get 1,683. And so now we should be able to check this by adding. So we do 1,683 plus 479. And so we get 3 plus 9 is 12. 1 plus 8 is 9. Plus 7 is 16. And we got to put the 1 over there. 1 plus 6 is 7. Plus 4 is 11. And we get 1 plus 1 is 2. So we get 2,162. I know I went a bit faster there, but we should be starting to get comfortable with the concepts. And of course, if you're not, then you can like and subscribe and you'll have access to some extra practice problems. So now moving on to translating word phrases to math notation. So we had the similar thing in the addition video. And so it's really, really important that you understand when we're looking at worded problems, what different terms mean. And so for subtraction, we're looking at things like minus, difference, decreased by, less than, or subtracted from. Some of those are kind of intuitive. Other might make you think about it. So if we say decreased by or difference, maybe it'll trip you up a little bit sometimes, but looking for those words is really, really important. And so some examples, we have 5 minus 1, the difference of 9 and 4, 7 decreased by 3, 5 less than 8, and 1 subtracted from 6. And so with these last two, we really need to think 5 less than 8 means 8 is the first number. And so we're subtracting 5 from that number. And the similar thing with the 6 and the 1. So we're doing 6 minus 1. So it is important to understand those concepts too. So now we want to translate and simplify. So A, we're looking at the difference of 13 and 8. So what does that mean? Well, the difference means that we're minusing or subtracting. And so the first number, we're finding the difference between 13 and 8. So we're going to go 13 minus 8. And so if we line this up, I'll just write it small over here. So 13 and 8, and we subtract. We get 3 minus 8. We can't do that. And then we carry the 1 over. This becomes 13 minus 8. And so you don't really need to line it up in this case, is the point I'm trying to show you. If we're just using 1 digit or 2 digits minus 1 digit, then we just have to kind of intuitively know those. So you can count down, or you'll end up just being able to work it out in your head eventually with enough practice. So 13 minus 8 is 5. And so you can kind of quickly check this in your head by saying 5 plus 8, or you go 8, 9, 10, 11, 12, 13. And so that would be correct. So then subtract 24 from 43. Well, we're saying from, so this is really key here. So that means 43 will be the number you're subtracting from. And so 43 will become, 43 will come first. And so 43 minus 24. This is one of those ones where you can practice doing your vertical columns. And so if we just write 43 on top, 24 on bottom, then we'll see 3 minus 4, can't do that. Make that a 3, borrow the 1, 13 minus 4 is 9, 3 minus 2 is 1, and we get 19. 19 plus 24, I won't prove it, but I know that that does equal 43. So that's how we would translate and simplify those worded problems. Okay, so now the most important part of this lecture, and this is where all of the different kind of tools that we're learning in these first few videos really start to play an effect. And so looking at application problems will be probably moving on towards like the biggest part of maths as we proceed into further math. And so these 4 steps are the same steps that we had from the last video where we talked about addition and adding whole numbers in application problems. And so I do recommend that you write them down. You don't have to write them down every time. They are the same, but really kind of internalizing this and keeping them next to you when you're doing any application problems will be super helpful. So the steps are to determine what we're asked to find, write a phrase that gives us the information to find it, then translate that phrase into math notation, and then importantly, a lot of students forget we want to write a sentence to answer the question and use the appropriate units where we need. So here's an application question, similar kind of worded style question. And so the temperature in Brisbane one morning was 38 degrees Celsius. It's a very hot morning. So a cold front arrived, and by midday, the temperature was 25 degrees Celsius. What was the difference between the temperature in the morning and the temperature at midday? So sometimes I like to go through and highlight things. So I'm looking at one morning, it was 38 degrees Celsius. And then by midday, the temperature was 25 degrees Celsius. So if we're finding the difference between the temperature in the morning and the temperature at midday, I would then look okay, well, the difference between the temperature in the morning says that the morning temperature is going to come first. And so I would just start by writing that out. So we've got 38 degrees Celsius. And what we want to do is we want to subtract the other number that we found in this problem. And so that happens to be the temperature at midday, which is 25 degrees Celsius. And so we can see that that kind of just creates our normal problem. Of course, there's units there, but it's basically the exact same problem. There's nothing that happens with the units. You actually don't have to write them the whole way through the working a lot of the time, but for clarity here, I will. And so 38 minus 25, we just do the same thing. So 8 minus 5 is 3, and 3 minus 2 is 1. And so carrying down the units, we realize that there's a 13-degree difference between the temperature in the morning and the temperature at midday. And so we would say something like the temperature at midday, mind my handwriting, the temperature at midday was 13 degrees Celsius lower than in the morning. And so a lot of the time, this is kind of the final piece that your teachers will expect, and to really show that you understand the concept. So a second application problem, we've got a washing machine is on sale for $399. Its regular price is $588. What is the difference between the regular price and the sales price? So here, I'm just going to highlight a couple of numbers so I know what I'm looking for. So sale price $399, regular price $588. Now we're finding the difference between the regular price and the sales price, which means the regular price comes first. And so because we highlighted that, we can clearly see that it's $588. And then the sale price is $399. And so now, thinking about what we're actually trying to find, we're finding the difference, which means we're subtracting. And so same process as before. So we go 8 minus 9. Well, we can't do that, so we have to borrow. So we end up with 7 there. And 18 minus 9 is 9. Then we get 7 minus 9. Can't do that. That becomes a 4. This becomes 17. 17 minus 9 is 8. And then 4 minus 3 is 1. So we can see there's a $189 difference between the regular and sales price. And so to write something so that our teachers know that we understand, we could say something like, there was a $189 price difference between the sale price, or between the regular price, sorry, and the sales price. So that brings us to the end of our subtraction lecture. And so a couple of really important ideas in there. I really want you to understand how to apply these skills and tools into application problems. I think a big part of this lecture is understanding all the different word phrases that represent subtraction. Because once you kind of understand how to use subtraction in terms of lining up the columns and then having the second number subtracted from the first, and borrowing and checking by adding and things like that, really where it becomes more difficult is by using it in worded or application problems. So I think a lot of time spent there and really internalizing that methodology or the steps I provided will help you go a long way in math. If you enjoyed this video, like, comment, and subscribe. If you have any feedback, feel free to throw it in the comments or reach out to our page. We'll see you in the next video.